Hello everybody, welcome to A to Z Learning Hub. We have already started set theory. Today I am giving you a question. Write a set in set builder form in symbolic notation. Suppose A is a set. We write A is equal to x such that Px. This is its symbolic notation of set builder form. Here Px is the defining property of a set. For example, A is equal to A, E, I, O, U. In set builder form we can write A is equal to x such that x is a vowel of English alphabet. You see, in this formula and here x same, here x is the vowel of English alphabet. For this we write Px. Px is the defining property of this set. Question will come, write a set in set builder form in symbolic notation. We write, suppose A is a set, so A is equal to x such that Px. Here Px is the defining property of this set. For example, if A is equal to A, E, I, O, U, then A is equal to x such that x is a vowel. X is a vowel is the defining property. Here Px is the defining property. Then we write power set. The set of all subsets of a set is called its power set. Suppose I write A is equal to 1, 2. So order of A is equal to 2. So number of subsets is equal to 2 to the power 2. 2 to the power n, that is equal to 2 to the power 2, that is equal to 4. Hence subsets are 1, 2, 1, 2 and 5. These are the subsets. So these are the subset means, so the power set of A, that is your PA, is written as you take all these elements are elements. All these sets as element, that is your 1, 2, 1, 2 and 5. So every set is the element and you give curly bracket, so PA. So it is clear that, so if order of A is equal to n, the order of PA is equal to 2 to the power n. Here order of A is equal to 2, here order of A is equal to 2, so order of PA is equal to 2 to the power 2, that is your 4. So power set means the set of all subsets of a set is called power set. If A is equal to 1, 2, so order of A is equal to 2, the number of subset is equal to 2 to the power n. Here n is equal to 2, that is equal to 2 to the power 2 is equal to 4. when subsets are 1, 2, 1, 2 and 4. I have already told you. So power set of A, that is PA, that is there 1, 2, 1, 2 and 5, and you give curly bracket. So like this. So power set is a set of sets. So we can say power set is a set of sets. In a power set there are so many sets. Next come to your proper power sets. The set of all proper subsets of a set is called proper power set. It is denoted by P of PA. Let A is equal to 1, 2. So order of A is equal to, that is equal to n, that is equal to 2. So number of proper subsets is equal to 2 to the power n minus 1, that is equal to 2 to the power 2 minus 1, that is your 3. So we can say its proper power sets are, so proper power sets are 1, 2 and 5. You don't write 1, 2 because the set of 1, 2 and 5 are proper subsets. So the set of all proper subsets is called proper power sets. So proper power set of A, this is your 1, 2 and 5. This is your proper power set. So in this case, order of A is equal to 2 means order of PPA is equal to 2 to the power 2 minus 1, that is equal to 3. This is your 1, 2 and 5. It is also a set of sets. Next come to your, this is the first part. Next come to your set operations. We can say it as Boolean algebra because it was given by George Boole. So it is called Boolean algebra. You know, in mathematics or in arithmetic, there are 4 operations. This is your addition, subtraction, multiplication and division. Similarly, in set, there are different types of operations like union, intersection. This is your union. Third one is difference. Difference means you give like this or like this. Next, fourth one is complement. You give symbol like this or C. Next come to your symmetric difference. Symmetric difference, that is your delta. And lastly, your Cartesian product. Cartesian product of set, you give cross. These are main operations. These are union, intersection, difference, complement, symmetric difference and a Cartesian product of the sets. These are the set operations. You remember all this. After that, we read set algebra. Now, we start union. You see, let union. let A and B are two non-empty sets, then their union is written as A union B. You can say it also A cop B. This is like cop A cop B. This is the A union B. It means A or B. The elements are present in either A or B or both. A or B. You see, remember it's a translation. A or B. Mathematically, A union B is equal to X such that X belongs to A, or you remember this point, very important, X belongs to A or X belongs to B, or X belongs to A union B implies and implied by X such that X belongs to A or X belongs to B. A or B, the elements are present either in A, it means you can write elements are present either in A or in B. You can write this. Let A and B are two non-empty sets, then their union is written as A union B. It means elements are present either in A or in B. Mathematically, A union B is equal to X such that X belongs to A or X belongs to B, or X belongs to A union B implies and implied by X such that X belongs to A or X belongs to A. That means if this is true, then this is also true, and vice versa. It is also true. Now, in Venn diagram, I can write like this. Suppose this is the universal set, you know, this is the universal set U, this is your A, this is your B, A and B, here A union B is like this. All these elements are present in A and B. This is your A union B. This is your A union B. This is the Venn diagram for union. For example, A is equal to 1, 2, 3 and B is equal to 4, 5, 6. Then A union B is equal to 1, 2, 3, 4, 5, 6. This is the union. If A is equal to 1, 2, 3, B is equal to 4, 5, 6, then A union B is equal to 1, 2, 3, 4, 5, 6. Another example I am giving you. Suppose A is equal to 1, 2, 3, B is equal to 2, 3, 4, 5. Then A union B is equal to 1, 2, 3. You don't repeat it because you know the elements are not repeated in a set. 1, 2, 3. This is your 4, 5. This is your A union B. That means 2 and 3 are not written twice and twice. They are written once. Next come to your extension of a union. Let A1, A2, A3 ... N are n sets. Then their union is A1 union A2 union A3 union ... union A. In short form you write union, you give big union AI, I from 1 to I is equal to n. So here you see there are n sets. this is equivalent to this is equal to this, A1 union A2 union A3 union AN, that is equal to union of I from 1 to I to N, that is your AI. I stands for 1 to N. This is the symbolic form. Now, I am giving you an example. Suppose A1 union A2 union A3 union A4 union A5. In symbol it is equivalent to union of AI, I from 1 to I is equal to 5, or you can write union AI, I is equal to 1 to 5. You can write like this. This is the union. Sometimes question will come in this form, you can extended like this, and suppose in extended form you can squeeze like this. This is your union. Next come to some properties of a union. You see, there are some property of a union like this. First property, A is the subset of A union B. Second come to your, if A is the subset of B and C is the subset of D, implies that A union C is the subset of B union D. You remember this. A is the subset of A union B. Second property is A is the subset of B and C is the subset of D, implies that A union C is the subset of B union D. Third property is, if A is the subset of B and A is the subset of D, then implies that A is the subset of B union D. If A is the subset of B and A is the subset of D and A is the subset of B union D. This is your third property. Fourth property is, union is idempotent. Idempotent. What do you mean by union is idempotent? That is, A union A is equal to A. A union A is equal to A. That means any set is in union with itself give the that set. Next, union is commutative. Commutative means, let A and B are two sets, then A union B is equal to B union A. Commutative. Commutative means A union B is equal to B union A. Sixth property, union is associative. What is the meaning of union of associative? For associative, you take three sets, A, B and C. That is the A union B union C is equal to A union B union C. A union B union C bracket is equal to A union B bracket union C. This is your one property of a union. Next come to your seventh property, A union phi is equal to A. Any set is in union with a null set, give that set. And your eighth property is A union E. Universal set, you can give U is equal to E. Any set is in union with universal set, give the universal set. And there are ninth property, that is your phi union phi is equal to phi. Null set is union with null set, give the null set. These are the property. First you see, how can we prove this? These are proved logically. You see how. First you see, A is the first property. A is the subset of A union B. You see Venn diagram. This is your A, this is your B, and whole is your what? A union B. How can you prove it? Proof, you see, let, this is obvious, from definition it is clear. That means we know, from definition we know X belongs to A union B implies that X belongs to A or X belongs to B. X belongs to A or X belongs to B. So it is clear that, from definition, so it is clear that A is the subset of A union B. You see, from definition we know X belongs to A union B implies that X belongs to A or X belongs to B. That means A union B is the bigger set and A is the part of A union B. So it is clear that A is the subset of what? A union B. Next come to this is your first proof. From definition it is already proved. Next come to your second part. Second part is A is the subset of B and C is the subset of D. We have to show A union C is the subset of B union D. You see proof. From LHS we start. Let X belongs to A union C. You see, X belongs to A union C. As it is given, you remember, as it is given A union C is the subset of B union D. So you remember, you always give this symbol. X belongs to A union C implies that X belongs to A or X belongs to C. From definition, it is clear. As A is the subset of B, we can write X belongs to B, and C is the subset of D, we can write X belongs to D. Here a bracket you write A is the subset of B and C is the subset of D. You write cos. So you can write X belongs to B or X belongs to D implies that X belongs to what? B union D. From definition. From definition it is clear. So X belongs to A union C implies that X belongs to what? B union D. From definition of a subset, so it is clear that, so A union C is the subset of B union D. You can write from definition of subset. In subset definition, I have already told you, let X belongs to A union C, if subset symbol, so you give implies sign, implies that X belongs to A or X belongs to C. From definition. This implies that X belongs to B, X belongs to A means X belongs to B or X belongs to D, because A is the subset of B. So you can write X belongs to A means X belongs to B. Since C is the subset of D, X belongs to C means X belongs to D. This implies that X belongs to B union D. So X belongs to A union C and X belongs to B union D. From definition of a subset, we can write A union C is the subset of what? B union D. Next come to your third property. Third property is A is the subset of B and A is the subset of D. You see, let X belongs to A. This implies that we can write X belongs to B or X belongs to D. Implies that X belongs to what? B union D. So X belongs to A and X belongs to B union D. So A is the subset of what? B union D. This is from given condition. This is your from definition. Definition, what is the definition? X belongs to B or X belongs to D means implies that X belongs to B union D. For every step you write the cause. This implies that A is the subset of what? B union D. It are from definition of a subset. You write like this. So A is the subset of B and A is the subset of D means A is the subset of B union D. Next come to your another property, third property, we have already told you. Next come to your fourth property, union is idempotent. Union is idempotent means A union A is equal to A. You see, you prove like this, prove. Let X belongs to A union A. When it is given equal sign, you give this symbol, implies and implied by. You remember this, when you given equal signs between the left hand side and the right hand side, you prove like this, implies and implied by X belongs to A or X belongs to A. So X belongs to A or X belongs to A, it is meaningless. You can imply and implied by, you can write X belongs to A. X belongs to A or X belongs to A or X belongs to A, directly you write X belongs to A. So X belongs to A union A implies and implied by X belongs to A, and X belongs to A implies and implied by from forward to backward. You see, if X belongs to A union A implies and implied by X belongs to A. From backward to forward, if X belongs to A implies and implied by X belongs to A union A. So we can say A union A is the subset of A, this is the first, and A is the subset of A union A, this is the second. So from 1 and 2 we can write A union A is equal to A. This is the union is a idempotent proof. Let X belongs to A union A from left hand side to right hand side. I will go right hand side to this point. Implies and implied by X belongs to A or X belongs to A. X belongs to A or X belongs to A or X belongs to A, it is meaningless. So we can write directly let X belongs to A. This is the first part. The X belongs to A union A means X belongs to A. Similarly, X belongs to A from backward to forward, X belongs to A means you can write X belongs to A or X belongs to A twice you can write. This implies that X belongs to A union A. So A union A is the subset of A and A is the subset of A union A. From 1 and 2 you can write A union A is equal to A. Next come to your union is commutative. That is A union B is equal to B union A. How can you prove it? First method, equal sign is given. Let X belongs to, proof, let X belongs to A union B. This is the hypothesis. Implies and implied by, I have already told you, when there is equal sign you give this sign, implies and implied by. You can write X belongs to A or X belongs to B by definition of a union. Implies and implied by X belongs to A or X belongs to B. As it is given, we have to prove A, B union A. We can write X belongs to B or X belongs to A. You can also write. This implies and implied by X belongs to what? B union A from definition. So X belongs to A union B. From, if you come from left hand side, X belongs to A union B means X belongs to, implies that X belongs to B union A, or X belongs to B union A implies that X belongs. So we can write A union B is the subset of B union A, this is the first part, and B union A is the subset of A union B, this is your second part. If A is the subset of B and B is the subset of A, from 1 and 2 you can write A union B is equal to B union A. This is the first method. Next come to your second method. Suppose here we prove from left hand to right hand side, again from right hand to left hand side separately. LHS. Let X belongs to A union B. You give implies that. You prove from left to right, again from right to left. X belongs to A or X belongs to B. From definition. Implies that X belongs to B or X belongs to A. You have not given double implication sign. This implies that X belongs to B union A. So, X belongs to A union B implies that X belongs to B union A. So, A union B is the subset of B union A. This is the first part. From definition of subset. Next come to your RHS. Let X belongs to B union A. X belongs to B union A. This implies that X belongs to B or X belongs to A by definition. This implies that X belongs to A or X belongs to B. B or A means A or B. This implies that X belongs to A union B. So, X belongs to B union A means X belongs to A union B. So, B union A is the subset of A union B. This is the second part. You do it separately. But in first method, I am do directly. By giving implies and implied by sign. Here I give only implied sign. Here A union B is the subset of B union A and B union A is the subset of A union B. From 1 and 2, we can write A union B is equal to what? B union A by definition of a subset. By property of a subset. What is the property of a subset? If A is the subset of B and B is the subset of A, then A is equal to B. This is your fifth proof. Next come to your sixth proof. Union is associative. Sixth method. A union B union C is equal to A union B union C. You see, proof. I am giving you in one step, that is the double implication sign. Let X belongs to A union B union C. Implies and implied by. That means I am doing both sides. X belongs to A or X belongs to B union C. Because it is in one side, it is in one part and these are in one part. Don't separate this in one step. Implies and implied by X belongs to A or X belongs to B or X belongs to C. By definition of a union, here also by definition of a union. X belongs to A or X belongs to B union C implies and implied by X belongs to, in next step you break it, separate it. X belongs to B or X belongs to C. But in RHS we are given A union B in one bracket. So you arrange like this. X belongs to A or X belongs to B in one bracket or X belongs to C. Next you see X belongs to, you join it, A union B or X belongs to C. Implies and implied by X belongs to A union B union C. You see, you give the RHS. So it is clear that if A is the, if X belongs to A union B union C, then X belongs to A union B whole bracket union C. Conversely, if X belongs to A union B whole bracket union C, then you can get, implies that X belongs to A union whole bracket B union C. So A union B union C is the subset of A union B is the subset of A union B union C, this is the first, and A union B union C is the subset of A union B union C. This is the second part. So from 1 and 2 we can write A union B union C is equal to A union B union C. Next, you come to another proof, seventh proof. A union phi is equal to A. Let X belongs to A union phi. Implied and implied by X belongs to A or X belongs to phi. This implies that X belongs to A because X belongs to phi is impossible, because no elements are present in phi. This is your by definition of a union. So X belongs to A union phi means X belongs to A and X belongs to A, because implied and implied by sign is given, X belongs to A means X belongs to A union phi. So A union phi is the subset of A, this is the first part, and A is the subset of A union phi. From 1 and 2 it is clear that A union phi is equal to A. Do like this. Let X belongs to A union phi. This implies and implied by X belongs to A or X belongs to phi. This implies and implied by X belongs to A, because since X belongs to phi is impossible. So A union phi, you get RHS. A union phi is the subset of A and A is the subset of A union phi. So from 1 and 2, A union phi is equal to A. Next come to another part. Question, another proof. This is your 8. A union E is equal to E. You see, this is your E and this is your A. Proof, you see, let X belongs to A union E, implies and implied by X belongs to A or X belongs to E. From figure you see it is clear that X, this implies that X belongs to E. X belongs to A or X belongs to E means X belongs to E. So A union E is the subset of E, this is the first, because implied and implied by sign is given, and E is the subset of A union E, this is the second. From 1 and 2, A union E is equal to E. And number 9 proof is phi union phi is equal to phi. It is obvious proof. It has no proof. You know phi. When phi is added with phi, we get phi. So it is always true and it has no proof. So these are the properties of a union. Using this property, question will come like this. You see, suppose question will come A is equal to 1, 2, 3, B is equal to 3, 4, 5 and C is equal to 6, 7. Verify associative property of a union. Associative property of a union. What is the associative property of a union? Question. That is A union B union C is equal to A union B union C. First you see LHS. Here A is given, that is a 1, 2, 3. And B union C. B union C what? This is your 3, 4, 5 and 6, 7. That is 3, 4, 5, 6 and 7. So A union B union C means your 1, 2, 3, 3 don't repeat it twice. There's your 4, 5, 6, 7. This is your LHS. Next come to your RHS. RHS is what A union B union C. First you find A union B. This is your A is 1, 2, 3 and B is 3, 4, 5. These are 1, 2, 3, 4, 5 and C is equal to what? 6, 7. So A union B union C is what? 1, 2, 3, 4, 5, 6, 7. So it is clear that, so we can write LHS is equal to RHS. So the law is verified. This is your property. Next come to your intersection. First operation, this is the union, and then next come to your intersection. Intersection, this is your cap. Union is the cup and intersection is the cap. Let A and B are two non-empty sets, then their intersection is written as A intersection B. It means the elements are present in both A and B. A and B, both A and B. Mathematically, A intersection B is equal to X such that X belongs to A and X belongs to B, or X belongs to A intersection B implied and implied by X such that X belongs to A and X belongs to B, like this. And that means the elements which are common in both A and B. You see Venn diagram. Suppose this is your universal set, this is your A and this is your B, A and B, and this part which are common in both A and B, this is your A intersection B. This is your A intersection B, which are common in both A and B. For example, suppose A is equal to, for example, suppose A is equal to 1, 2, 3, 4 and B is equal to 4, 5, 6, 7. So you can write A intersection B is equal to what? Which is common? 4. This is your only 4. Another example, suppose A is equal to 1, 2, 3 and B is equal to 1, 2, 3, then A intersection B is equal to what? 1, 2, 3, like this. So suppose another example, suppose A is equal to 1, 2, 3 and B is equal to 4, 5, 6. That means A intersection B is equal to 5 because they have no common element. Here this is the 1, 2, 3, this is the 1, 2, 3. A intersection B is also 1, 2, 3. You see, next come to your extension of intersection. Let A1, A2, A3 dot 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 AN are n sets. Then their intersection is A1 intersection A2 intersection A3 intersection dot 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 intersection AN. You can write in a symbol, you give the intersection sign. This is your AI, I from 1 to I is equal to N, or intersection AI, I from 1 to N. You can write this. If suppose in short form, you can extend it like this, and if it is in extended form, you can write like this. This is your extension of intersection. Next come to your some properties of intersection. First property, A intersection B is the subset of A. Second property, A is the subset of B and C is the subset of D, implies that A intersection C is the subset of B intersection D. Third property is A is the subset of B and A is the subset of D, and implies that A is the subset of B intersection D. Fourth property is intersection is also idempotent. Idempotent, that is the A intersection A is equal to A. Fifth property, it is commutative, that the A intersection B is equal to B intersection A. Sixth, it is also associative, A intersection B intersection C is equal to A intersection B intersection C. Seventh property, A intersection phi is equal to phi. Eighth property, A intersection E universal set is equal to A. And the ninth property, phi intersection phi is equal to phi, like union. I have certainly forgotten one thing. If let A and B are two sets and they are disjoint, that means they are not joint, then A intersection B is equal to what? Phi. Like this. Suppose this is your E and this is your A and this is your B, A and B. Here A intersection B is equal to A intersection B is equal to phi. You remember important thing, let A and B are two sets and they are disjoint, then A intersection B is equal to phi and their Venn diagram like. And these are the property of intersection, and in the next class we will start difference. In today's class, if you like my teaching, please subscribe my channel so that I will be motivated to give and more interesting. Thank you for this day.